So this video will take a look at how we derive the exponential function e, including in this new rule called the chain rule. So let's start with the idea that we have a function y equals e to the x. Well, the really nice and easy thing about this is that the derivative, which we call dy dx, or sometimes we call y prime, right? Either you want to use, the derivative is actually itself. And so we really don't have to work too hard to get that derivative. Now, that's not going to be the end of the video. We have to work with other examples that might be maybe a little bit more involved. So the first example that you'll see in your notes is y equals 5x to the fourth minus 3e to the x. So this is also kind of piggybacking off of what we said the other day. So we have two different functions we're going to derive here. Right, let's look at the one we definitely know how to do, right? We've talked about 5x to the fourth, so using our little power rule here, this derivative would be 20x to the third, right? And then we know that this 5, just like this 3 here, always just kind of hangs out there until we handle what's next to it. So we just learned that the derivative of e is itself. So basically, you actually wind up just rewriting this term. So your final derivative here, when all is said and done, would just be 20x cubed minus 3e to the x. So the next two examples are going to be a tad bit more involved. So once we're done with that, you'll get a good idea of where you're looking to apply this idea of a chain rule. All right, so example 2, right, is y equals e to the x squared plus 1. Now, we have a much different problem on our hands here because we have an issue where we have an exponent that's way more involved than just x. So let me backtrack just for a second here. Right, a minute ago we said that the derivative of e to the x was itself. And that is because the derivative of e is itself, and then the derivative of x is 1. So there's this thing called the chain rule, and the chain rule deals with what we call a composition of functions. So in other words, if you have e raised to a power, right, let's call it u, the chain rule says that the derivative of that is going to be the repetition of e itself, but then we're going to have to take the derivative of u with respect to x, meaning in terms of x. So this is something we need to look for. So let's translate that into this second example, because it could be a little confusing, right? So we're trying to say that u is equal to x squared plus 1, right? The derivative of u is 2x. So from this point forward, when we go to find the derivative of e to the x squared plus 1, yes, we need to rewrite it, but then we have to multiply that times the derivative of that exponent, and we've already done that. That's 2x. So that would be your final derivative for a function like that. So beyond just e to the x, we have to look at that exponent to make sure we derive that and tag that along as well. Let's look at one more example. So in this third example, we start off with y equals 15 e to the 7x. So just like we talked about on the previous example, we have an exponent here that's 7x. That derivative of that exponent would just be 7. So how does that translate to what we're doing over here, right? Well, the derivative of this, right, we know that the 15 is a constant, so it tags along when it's multiplied times something else, right? So then we say, all right, well, what do we multiply that by? Well, we rewrite e, as we've been talking about for these examples, right? And then we have to make sure we multiply by the derivative of the exponent. And so in this case, that's 7. So can I clean that up? I can, just a little bit, and that's how we're going to end it here. All right, y prime is going to equal 105 e to the 7x. Where did I get that 105 from? That's just multiplying 15 times 7. So now what you want to do is get with other people in the class who have the same group as you, these exponential functions. And there's 3 more to practice in the notes, and then you're going to go back to your original group and try and teach them what's going on with these exponential functions.